Hello students, in this video we are going to find the derivative of given integral function using second fundamental theorem of calculus. But the function involves two variables. One is x, other is t. One variable x is same as the upper bound and the other variable is t. So what we can do, first let's take out this x term outside the integral part, because this integral function is in terms of t, so we can write the x part outside, which is a constant. Let's take the derivative of both sides. Derivative of y is dy over dx equals okay. So we can see here these are two parts. One part is having the x variable, other part is having the t variable. So we can apply the product rule of derivatives, which says take the derivative of first part keeping the second one same. Here the first part is e to the x, so derivative of e to the x is taken and the second part is written as it is. Second integral part is written as it is, plus e to the x is written as it is, and the derivative of integral part is taken, d over dx of integral from 1 to 10x okay. E to the, what's the derivative of e to the x? Derivative of e to the x always remains same, so it's e to the x integral 1 to 10x of 1 plus t square dt. Okay, for this part, for this integral part, we are going to apply the second fundamental theorem of calculus, because we need to find the derivative of this integral part. Now see, this is the right format to be able to apply the second fundamental theorem of calculus. The lower bound is a constant, upper bound is in terms of x, and the integral function is in some other variable, which is t. So the second fundamental theorem says, as we solved in the previous video, what we do, we just replace the variable t with the upper bound, with the given upper bound. So t square get replaced with 10x squared times the derivative of upper bound is written along with. So the derivative of 10x is written along with. So here we apply the second fundamental theorem. Okay, do you see this part is similar to anything? What we can do with this part? Isn't it the same as the original function? You can observe this part is same as this. So this was the given original function. We can replace it with y. So this part can be replaced with y. and the second part is simplified to 1 plus tan squared x times the derivative of tan x is secant squared x. So we can write the derivative dy over dx equals y plus e to the x, and 1 plus tan squared x, we can apply the identity over here. It can be simplified to secant square x. 1 plus tan squared x is equal to secant squared x. And this part can be simplified a little further. Secant squared, this squared can be eliminated with the square root outside. So we are left with just secant x times secant squared x, and finally we get secant x times secant squared x gives you secant cubed x. So this is the final answer. Dy over dx, the derivative equals y plus e to the x secant cube x. So this is how we solve the derivative. We take the derivative of given integral function when it involves two different variables. I hope you understood this concept. Stay tuned for our next video. Take care. Bye bye.